we have discussed about the sign of slope and velocity. Suppose you are having a graph over here. Suppose graph is something like this. So this is what the velocity and this is what the time. So suppose here velocity is positive, acceleration, that is slope is also positive. So what you can say, velocity is increasing, or you can say it is accelerating. Body is accelerating. Okay, body is accelerating. Similarly, if the graph is like this, so here what will happen? Obviously velocity is positive here, time here. So velocity is positive only. But what about acceleration? Acceleration is going to be, so what is that? V2 minus V1, greater minus smaller. So acceleration is going to be what? Negative. If they are opposite signs, we already know that velocity decreases. So here what velocity is decreasing, so that we can call it as retarding or de-accelerating. Okay. So this is what the two cases. Similarly, we have also discussed about this one. So if graph is something like this, so here what is happening? Velocity is already negative. Velocity is already negative. So phi is what? Phi is negative. Then what about acceleration? This is what going to be your slope. This is what you are going to be your slope. So slope is, so this is V2 and this is V1, minus V2, minus of minus plus V1. So V2 is greater. So your acceleration is going to be what? Your acceleration is also going to be negative. So what will happen? So what will happen? Both are having the same sign. So what you can say? You can say again velocity is increasing. From the graph you can understand. So what you can say? Body is again accelerating. Body is again accelerating. Okay. So similarly another graph we can take here. Again velocity is going to be negative and time is what, as usual, along the x-axis. So what I can take the graph in this direction. Okay, from here. So what will happen here now? Velocity is what? Velocity is negative. That is not a problem. Velocity is negative. Then what about the slope? If you take the slope here, so you can understand slope is going to be what? A is going to be what? Positive. So here opposite sign. So what you can say here, from the graph velocity is decreasing, of course. But what about the acceleration? It is not going to accelerate because opposite sign, velocity and accelerations are of different signs. So what you can say? Body is de-accelerating. Okay. So from the graph you can understand when body is accelerating, when bodies are de-accelerating. Okay. So like this, if suppose if I give you one graph, you should be able to describe the motion. Suppose for example, if I have taken a graph from here and just I will decrease this. So if this is the graph I have given to you, so you should be able to describe the motion. Finding slope and other things are different, but at least you should be able to describe motion. What is happening actually here? So suppose if I identify this as A, B, C, D like this. So here what I am making, it is velocity time graph V versus T. So how you can describe? So here you cannot give a single statement or single conclusion, because it is not constantly increasing or decreasing. So graph is changing a different place in different directions. So what we can say is A to B. If you look at here, velocity is what? Velocity is constant. Velocity is constant means velocity is uniform. It is not changing. So if velocity is not changing, can you calculate the slope here? You cannot calculate the slope. So slope A is going to be what? A is going to be 0. Means body is not accelerating, but it is moving with a constant velocity. So from A to D, what you can say? Body is moving with constant acceleration, not acceleration, velocity, with constant velocity. Okay. So what about acceleration? Acceleration is 0 whenever what velocity is constant, so you can say acceleration is 0, means body is not accelerating, you are not increasing the speed. So now from B to C, here what is happening from B to C? So if you look at the velocity axis, so velocity is what? Velocity is decreasing. Velocity is decreasing. So if you calculate the slope over here, if you calculate the slope over here, what is happening? Velocity is decreasing. What about the slope? Acceleration is going to be what? Acceleration is going to be negative here. If you look at this graph, which one? If you look at this graph, A is negative here. So A is negative. That means velocity is decreasing. So V is positive, A is negative. So what is happening? You can say that it is deaccelerating, or you can say it is retarding. It is retarding. Okay. So from B to C, what is happening? From B to C, what is happening? Velocity is decreasing, or body is retarding. Body is retarding, or you can say velocity is decreasing. Velocity is decreasing. Okay. So at C, what will happen? At C, velocity becomes 0. At C, what will happen? At C, velocity becomes 0. Means what? Body comes to rest. Body comes to rest. It was moving in this direction. Okay. So at point C, so from A to B, what is happening? It is velocity is constant. Velocity is constant. From here to here, velocity is decreasing. Decreases and becomes 0. Okay. Now it comes to rest. Now from C to D, what is happening? Velocity suddenly become negative. Here, P is what? Negative. Velocity suddenly become negative. So velocity is negative. If you look at the slope, A, that is also what? That is also negative. Velocity is also negative, slope is also negative. If both are negative, what is happening? Only direction is changing, means after we return. So what is happening? It is returning, but its velocity is increasing. Velocity increasing. Getting the point? Means what? It is again accelerating. Accelerating. It is again accelerating. So from C to D, what is happening from C to D? C to D, first of all, velocity becomes negative, means there is a change in direction. Body changes direction, or simply you can say moving with increasing velocity along what? Velocity increasing, moving with increasing velocity in what? Negative x direction. Or you can say opposite direction of the before. Here it was moving what? Here it was moving with positive x direction. Now it is what? Returning back, means it is moving along the negative x direction. Okay. So like this, you should be able to what? You should be able to describe the motion. Then only what you can understand what is happening with the motion. Okay. So this is what how we can describe the motion of. I will take similar example. We'll see can we able to describe the motion or not. Okay. So this is what V. This is what minus V. Here it is along T. So what we can write? T you can take from this. So graph we can take. Will take little different. I will take like this. Then it is moving on the axis here. Then it is coming like this. So A, B, C, D. So how we can describe the motion? Okay. First from A to B. A to B. What is happening from A to B? From A to B. See here. Velocity is what? If it is 50 here, it is coming 40, 30, 10, 0 like that. So velocity is what? Velocity is decreasing. Velocity is decreasing. What about the slope? Slope is positive or negative? Slope is going to be what? Negative. So A is what? A is negative. So V is positive, A is negative. Opposite signs means what? It is velocity is decreasing means it is what? De-accelerating or retarding. It is slowing down. Velocity is decreasing. That we can say that it is de-accelerating or retarding. So from A to B, what is happening? Velocity decreasing. Velocity decreasing. That is, body is retarding. Body is under retardation. Under retardation. Whatever we can write, no problem. You can simply write velocity is decreasing. That is not a problem. If you look at from B to C, what is happening from B to C? B to C, velocity is 0. There is no velocity. So V is 0. V is 0 means what? Body is at rest. Body is at rest. So V from B to C, V is 0. It means that what? It means that body is at rest. Body is at rest. Okay. Now from C to D, what is happening? From C to D, what is happening? So velocity is decreasing. Velocity is decreasing and it is what? Negative value. So V is negative. What about the slope? What about the slope? Slope A is also what? A is also negative. If both are of same side, what is happening? Body is accelerating. Body is accelerating. Okay. So now what is happening? Body start again moving with increasing. Velocity is not decreasing. Velocity is increasing, but in opposite direction. So velocity is increasing, but in opposite direction. Okay. So body moving with increasing velocity. Body moving with increasing velocity in opposite direction. In opposite direction, or you can say it is now moving along the negative x-axis. So what is happening here? It started with some high velocity. So here from A to B, what is happening? Velocity is decreasing. From B to C, it is at rest. From C to D, what is happening? It is coming in this direction. Again, velocity is what? Velocity is increasing. Okay. So this is what the motion, how we can describe from this graph. Okay. So like this, we should be able to describe the motion of any motion from any graph. So now we'll take one important example in which everything is going to be covered: speed, velocity, distance, displacement. But graph is what? Graph is VT graph only. Remember, graph is VT graph only. Okay. So suppose graph is given like this. This is V. This is also V, but negative, and this is what? Time. Okay. And your graph is like this, simple. So time is what? From here to here we can say 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 6, 7, 8, 9, 10. Okay. So this is what the graph. So this is what? 10, 9, 8, 7, 6. So this is what? Plus 10, and this is what? Minus 10. So this much graph is given. They may ask you to calculate distance or displacement. They may ask you to calculate what is the average velocity, or they may ask you to calculate average speed also. Okay, 4 possibilities are there. They may ask distance, displacement, average velocity, or average speed. So how we can do this one? To calculate the distance or displacement, what is required? The required is area under the curve. Okay. First we will calculate area under the curve for whole journey. So from here and this is what area. So this is what area, and here also area will come. Okay. So this is what the area. So total area, what it will be? Area of this triangle A, B, C, and you can say one more is B, D, E. Okay. So calculate area separately. Area of A, B, C first. So area of A, B, C. So what it will give? Triangle ABC. So you can take this as area 1, A1. So what is this? Half into height. Height is what? 10 plus. So width, so 5. So what you will get? You will get it as what? 2 5 so you will get it as 25. Okay, this is what area. But what area will give? Area will give distance or displacement. Okay, now you calculate this area. So this area A2 is again half into what is the width? Sorry, height is 10 and width is 5. So this also what? This also going to be 25. So area 1 is what? 25 meter. Area 2 is also what? 25 meter. But in area 2 you will get negative sign. If you take this as minus 10, if you get this as minus 10, if you take it as minus 10, so this is going to be what? This is going to be what? Minus 25. Okay. Now what exactly body is taking place? Body is moving in this direction. So velocity becomes 0 means it comes to rest. Then its direction is changing. Velocity is become negative. So velocity is becoming negative. So it started from here and again come back to the same point. So that is why both the directions are, here V is positive, here V is negative. If you want to calculate distance, for distance sign is not required because it is not a vector, it is a scalar. So for distance what you can do? 25 plus 25, so it will become what? 50 meter. Yes or no? Because area under the curve gives you what? Area under the curve give you either distance or displacement. If you consider sign, if you do not consider sign, it is going to be what? Distance, no sign. Okay, no sign. If you consider sign, it is going to be what? Displacement. Now for distance, no need to consider the sign. This will become what? 50 meter. If there is displacement. So for displacement, you have to consider this sign because displacement is having the sign. It have the direction. So you have to consider sign. So displacement will become what? 25 minus 25. So what you will get? You will get it as 0 meter. You will get it at 0 meter. So now, so what is happening here? Displacement is 0, means body is coming back to its original position, correct? So it moves 25 in this direction, 25 in this direction. So total distance is 25 plus 25, 50 meter. Displacement, there is no displacement. Displacement is 0 because it is coming to the original position. So that is why displacement you are getting 0. Okay. Now if they ask what is the average velocity? Average velocity. So average velocity is equals to what? Total displacement divided by total time. So total displacement is what? 0. So 0 divided by time will give what? 0. So average speed. What is the average speed? Average speed is going to be total distance divided by total time. Okay. So total distance is what? Total distance is 50. Time taken is what? From here to here 5 minutes. Sorry, 5 seconds. From here to here it is 5 seconds. So total is 10 seconds. So this will become what? 5 meter per second. This is what average speed, and your average velocity is going to be 0 because total displacement is going to be 0. Okay, so this is what how you can calculate the distance, displacement, or average speed or average velocity. Okay, so now I will give similar graph so that you have to calculate. What you have to calculate? You have to calculate distance, displacement, velocity, and speed. Okay, so for example, so I will give a graph over here. Simple graph. I will not give negative or something. So graph is simply like this. So this is what the graph. Okay. Here you can take it as a 2. Here you can take it as 3. So 2, 4, 6, 8. So here you can take it as 10 plus 10. So here velocity is there. Here time is there. Okay. What you have to calculate from this graph? You have to first calculate distance. So distance, since it is not going in negative, means distance may be equals to displacement also. Okay, so displacement, distance and displacement you have to calculate. Then what you have to calculate? You have to calculate speed or velocity, because not changing direction means you may get similar. Okay, so try with this one. What you have to calculate here? You have to calculate area. Okay, how you can calculate area? You divide the graph. This is going to one triangle, so you calculate this half into 10 into 2. Okay, this is going to be 1. This is going to be 1. That is what rectangle. Okay, so this is what 10 into 6 minus 2, so 4. So this distance into this. So this is one area. This is A1. This is what A2. Again this is one more. Again this is one more. Half into what is that? 10 into 8 minus 6, so 2. So this is what your A3. A1 plus A2 plus A3 gives you what? It gives you the distance or displacement. Okay, you can calculate just distance or displacement, speed or average speed or velocity. So simple, total distance divided by total time. I hope you can easily calculate area 1, area 2, area 3. Area 1 is what? Area of triangle, half into height into base. Area 2 is what? A rectangle. So what you can say? Length into breadth. So this is what? Rectangle. This is area 3 is what? Again a triangle, half into height into what? Base. So you can just calculate area 1, area 2, area 3 and add them. You will get the total distance or total displacement. So now we will take one example based on acceleration. Okay. So now we are having the graph over here. So look at the graph properly. So graph is something like this. Here in the graph we have the say 20, say 40, say 60, 80 like that. This is our velocity meter per second. Okay. Here you have say 10, 20, 30, 40, 50, 60, 70, 80 like that. Okay. So now here what is happening? So graph will be like this. So beginning till 20 it is increasing. So till 20 it is increasing. Okay. So better if we take a dotted lines. Okay. From 20 to 30, what is happening? It is going to be rest. Velocity is going to be say constant, not rest. Velocity is going to be constant. Again from 30 to 40, it is suddenly increasing to say some 60. It is suddenly increasing to some 60. Okay. So this is what going to be 40. Okay. So this is what the graph. It is suddenly going here. Now from there it is suddenly coming to 70. Okay. So this is what the graph. What is question? Question is, what is the maximum acceleration in the graph? What is the maximum acceleration? So what is the maximum acceleration? They make you answer that is 1 meter per second square. Your option B is what? 2 meter per second square. Or option C is what? Meter per second square. So your option C may be say some 3 meter per second square. Option D say some 4 meter per second square. I don't know whether our answer may be there or not. Like that they may give the confusing answers. Okay. So here maximum acceleration. For that we have to find accelerations in different curves. Okay. Where your slope is maximum, their acceleration is going to be maximum. Okay. First I will calculate here. This is what slope 1. Slope 1 means acceleration 1. So slope 1. So what is slope 1? This is what? 20. 20 divided by, this is what? From here to here. It is 20. Okay. So you can write like this, 20 minus 0 divided by 20 minus 0. Okay. So slope 1 is 20 minus 0 divided by 20 minus 0. So what it is going to be? It is going to be 1 meter per second square. Okay. So acceleration 1 is what? 1 meter per second square. That answer is there in the given options. So next, from here to here, velocity is constant. Velocity is constant means what? Acceleration is 0. So slope 2 is 0. Means A2 is what? A2 is 0 meter per second square. But that option is not there. Okay. Here, I will take one more slope for here. This is what the one more slope. So now here slope 3. Slope 3 is what? This divided by this. What is this one? So from here to here. Okay, this is what the slope. This is what slope I am considering. Okay. So slope is 60 minus 20. 60 minus 20 and this one. This one 40 minus 30 means 10. So slope 3 is 60 minus 20 divided by 40 minus 30. 40 minus 30. So what you will get? You will get it as say 40 by 10. That is 4 meter per second square. Okay. So your A3 is what? A3 is 4 meter per second square. Okay. That is what acceleration. Now slope 4. Slope 4 is this one. This is what your slope 4 from here to here. This is what your slope 4. Slope 4 is 60 minus 0, 70 minus 40. So 60 minus 0, 70 minus 40. That is 60 divided by 70 minus 40 is what? 30. Okay. So this will go 1, 2. So 2 meter per second square. Okay. But while calculating, what will happen? This is what 60. What is your V2? V2 is going to be 0. It is 0 minus 60. So that we should take care. That is 0 minus 60. It will become what? Minus 60. So this will become minus 2 meter per second square. So A4 is what? Minus 2 meter per second square. Now look at your options. 1 is also there, 2 is also there, 4 is also there. Okay, 3 is only not there. So what they are asking maximum acceleration. Maximum acceleration. So maximum acceleration means, so which is having maximum value? 4. And this is 1 and this is what? Minus 2. Okay. So 4 is what? 4 is what? Maximum acceleration. Okay. Suppose your answer will be say some here it is coming some 2 or something. If this is also, this is going to be some minus 5 meter per second square. then also you should go forward, you should go for 4 only. Why? Because negative sign means what? It is not acceleration, it is going to be what? Retardation or de-acceleration. So our answer should be what? Our answer will be what? 4 meter per second square. Okay.